Anaerobic digestion is a promising technology offering many benefits to society. Far too often, though, this method of organic waste treatment is touted only for its ability to produce renewable energy. However, anaerobic digestion also helps improve air and water quality, reduce greenhouse gas emissions, and can even be a source of job creation for local economies. Furthermore, the next generation of anaerobic digesters is at the center of a system of technologies capable of producing even greater benefits.
Digesters have been around for a while, but we've got new technology that allows us to take this to a better place economically and environmentally.
Traditional methods of dealing with the organic waste stream include sewage treatment plants, aerobic lagoons, compost yards, and landfills. However, unlike anaerobic digesters, these solutions more often than not consume rather than produce energy. Digesters come in many different designs. Some treat municipal sewage or urban food waste. Others process animal manure. In this video, we will use the example of a rural dairy-based system. But whatever their design, all digesters follow the same underlying concepts.
Anaerobic digesters are basically carbon conversion tools. They simply take the organic carbon that's inside the manure and turns it into a gaseous inorganic carbon, which is called biogas. Biogas is methane and carbon dioxide. It's the methane that we really want. We can use it for fuel or as power or electricity.
Without anaerobic digestion, manure management has traditionally been limited to simply storing untreated manure in lagoons and later applying the untreated liquid onto fields. However, this practice leads to potential air and water quality issues, such as nutrient overloading to soils, release of phosphates and nitrates to water supplies, and emissions of odorous volatiles, ammonia, and greenhouse gases, such as methane and nitrous oxide. Anaerobic digestion, as part of a system of integrated technologies, can address all of these issues.
It gives us the diversification to have more than one item to sell, and also helps us control the nutrients, the manure, and that sort of thing.
At the center of the system is the digester itself, basically a sealed tank where the organic material is broken down. On this dairy farm, cow manure and potentially off-farm organics from the community are collected in a holding pit, then pumped into the digester. The tank mimics the digestion process of an animal's stomach. Inside, the liquid is heated, agitated, and mixed in an air-free environment. This converts the solid carbon in the manure to biogas, which is collected, cooled, and used to power an electrical generator. The electricity can be sold to the local utility and sent out to the grid. The system itself creates the energy needed to keep the process going. Temperature and flow are maintained using excess biogas and heat reclaimed from the generator set. After the biogas is captured, the treated manure is pumped to a separator where the liquid is removed. The remaining solids can be used by the dairy as bedding for their animals or even sold for profit as a soil amendment or peat moss replacement. The treated liquid is stored in a lagoon for watering crops. Unlike untreated lagoon water, this liquid is significantly reduced in pathogens and virtually odor-free. For the current generation of anaerobic digesters, this is where the treatment process usually ends. However, even greater benefits and value can be gained by adding additional components to the system. One example is nutrient recovery.
Anaerobic digesters by themselves do not do a very good job of treating the nitrogen and phosphorus in the manures or organic waste. If you have too much fertilizer, too much nitrogen and phosphorus, it can be harmful for the soil and the plants. That's the case at some of our large animal farms. Therefore, we need nutrient recovery units to be associated with our digesters.
Nitrogen, in the form of ammonia, can be reclaimed using a revolutionary new technology developed by Washington State University and its industrial partners. The process is far less expensive than existing methods.
We can collect it and then make it into an ammonia sulfate fertilizer that farmers traditionally have used for years. An added benefit is that during this ammonia production process, we cause the phosphorus to settle out. So we get a 2-for-1. These concentrated biofertilizers can be used by the farmer and displace what they presently are doing in buying fossil fuel-based fertilizers. A combined digester and nutrient recovery system is a win-win because we make renewable energy, we solve a concern with nutrients, and we make revenue for the local community.
Another add-on technology relates to the scrubbing and compression of biogas. In this type of system, biogas is converted to renewable natural gas fuel instead of being used to generate electricity.
We're just in the middle of a tip from petroleum-based fuels to methane fuels, natural gas for trucking fleets and for cars. We have the technology now to produce renewable natural gas from the biogas that comes off the digester. It's clean to pipeline standards, is available for vehicle fuel for half the price of diesel.
While biogas scrubbing and nutrient recovery are already at commercial scale, pyrolysis and other related technologies are currently in development and hold great future promise.
In the future, we'll be able to take this the next step to clean, even drinkable water.
Construction of anaerobic digester systems helps state and local economies as well. In addition to tax revenue, it is estimated that in the state of Washington, for example, each digester project creates 15 to 20 full-time jobs during construction and 2 to 3 permanent positions for its operation. Despite their initial capital cost, with well-conceived business models, anaerobic digester systems offer significant economic savings and environmental benefit over the long term.
Everything kind of comes in, goes around, and goes back out as something usable.
There are synergies with this systems approach. We not only have the digester, but we've got these additional units that we can plug on, and that requires more capital, but also generates a lot more revenue, making a more profitable package and making this more replicable.
The advantages of anaerobic digestion are well documented. Waste management, renewable energy, biofertilizer production, greenhouse gas reduction, and more. With the incorporation of existing technologies and the development of future ones, the benefits will only continue to grow.